roots. Now what are they? That is what we are going to figure out. Remember in the previous chapters I've been talking of say 2 to the power of 2, right, which is nothing but 4. Similarly 3 to the power of 2 is 9. We have been talking of this. But suppose we look at it from the opposite direction. Let's say we have been given a number like 25, right? Remember 4 is 2 into 2. So that means a number multiplied by itself gives you 4. Similarly, another number multiplied by itself gives you 9. When it comes to 25, what is that number which when multiplied by itself gives you 25? That is 5 into 5. Are you getting this? So one of the way of looking at is 5 into 5, or if we talk in terms of exponents, 5 square is 25, right? So if we go in this direction, it is exponents. But if we go in this direction, then it is roots. To 25. Now the question is, what is that number which when multiplied by itself gives you 25? Now how do I put that? Using symbols. Remember, mathematicians love symbols. So the symbol that is used is this. And this is called a square root. Square root symbol. And just by putting this symbol around 25, we are asking that question. What is that number, or find a number which when multiplied by itself 2 times, or in other words, when it is raised to the power of 2 gives you 25. So what is that? We know it is 5 into 5. So square root of 5 into 5 is 5. Let's do examples. Let's do lots of examples. Okay, so square root of 49 is 7. Square root of 36 is 6. 6 6 is 36. 7 7 is 49. Square root of 9 is 3. Square root of 16 is 4. We can keep asking it to recalculate. Yes, let's keep clicking here. Okay, as and when we find a new number. So square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Okay, let's take any one of them as an example and work it out. 64 is equal to 8. If I remove this symbol, what should I do to keep them equal? I have to square it. If I remove the square root, I have to square on this side. If I remove this, I have to put a square root. Then only they will remain equal. That is one thing. Second thing is very important, is that when we use this symbol, we are talking of the positive root. Because what is that number which when multiplied by itself gives you 25? Actually, there are two numbers. One is 5 into 5 will give you 25, but minus 5 into minus 5 will also give you 25. Both of them will give you 25. But when we use this symbol, we mean 5, positive 5, and not the negative 5. If we want to specify negative 5, then we have to put a minus symbol outside the square root. Yes, minus square root of 25 is what? Minus 5. But when we write x square is equal to 25, what is the value of x? Try to understand this. When we say x square is equal to 25, what is x? If the question is like that, then you have to write that it is plus 5 or minus 5. Because in place of x, if you put 5 square is 25. In place of x, if you write minus 5, that is also 25. So the answer to this question is plus or minus 5. But the answer to this question is 5. Be very clear about this. Now here we were talking of multiplying the same number twice to get the square, or finding a number which when squared gives you the number. Same way we can look at a number which when cubed, that means when it is raised to the power of 3, gives you a number. Say for example 8, right? Now this is equal to what? 2 to the power of 3 also. 2 into 2 into 2, 2 to the 4, 4 to the 8. So if I remove this 3, what happens here? Same logic as before. We had 4 is equal to 2 square. So if I remove this, I have to put this. So if I remove cube here, I will have to put what? A root, that is sure. But it can't be square root, right? Because 2 into 2 is not, because 2 into 2 is not 8. It has to be 2 into 2 into 2. So what we do is we use the same symbol, but we write a 3 here. Right? Normally when a number is not present, we say it is 1. You should look at it as 1. But here in this case, if a number is not present here, it means 2. Right? See here, square root of 2. So number is not there. We don't write 2 here. So when a number is not present, we are talking of 2 square root. But for any other root, we'll have to explicitly write the number. Okay. Similarly, given this 8 is equal to 2 cube. No. Cube root of 8 equal to 2. If I remove this cube root, I will have to put a power of 3 here. Okay, let's do some exercises. Cube root of 125 is what? 5 into 5 into 5. 5 5 is 25, 5 is 125. So the answer is 5. Or what you can also do is you can do it step by step. 5 into 5 into 5. Right? For every set of 3 5s, you write 1 5 without the root symbol. Okay. Cube root of 64. Now let's say you don't know. What should we do? Start dividing. 64. Start dividing with prime numbers itself. So 2 3s are 2 2s are 2 16s, 2 8s, 2 4s, 2 2s, 2 1s. Yes. Now write all those. 2 into 2 into 2, 6. 2 into 2 into 2 is 336. Now put them in sets of 3. So one set, second set, right? Now for each set of 2's or each set of a number, write 1 multiplied by what? Another set. Now this time don't put the root. So the answer is what? 4. How do you check whether it is correct or not? Remember, 3 to the power of 64 is equal to 4. We have just now calculated this. If I remove this, what should happen? This should become cube. So 4 into 4 into 4. 4 4s are 16, 4s are 64. So did we get back? Both the sides are equal. So that means our answer is correct. Okay, same way 343. Right? Cube root of 343 we have to find. Start dividing. Does it divide by 2, 3, 4, 5, 6. 6 5s are 30. 43. 6 7s are 42. No. 7. Now what is the divisibility rule for 7? 343. Take this, double it. So 34 minus 6 is how much? 14 minus 6 is 8. 2. So this is divisible by 7. That means this is divisible by 7. So 7 4s are 28. 63. Right? So 7 9s are 63. 7 7s are 49. So which means what? It is 7. Or step by step, if we say cube root of 7 into 7 into 7. One set. So take it out. Similarly, cube root of 216. So 216, start dividing by 2. 2 1s, 2 0s, 2 8s, 2 5s, 2 4s, 2 2s, 2 7s, 3 9s, 3 3s, 3 1s. So this can be written as what? 2 into 2 into 2 into 3 into 3 into 3. So set of 3, set of 3. So for each set of 3's, take it out once. So 2 into 3. So that is 6. Again, how do you verify? Just take 6 cube. 6 6 are 36. 36 times 6 gives you what? It should come to 216. So because this is very useful in solving a lot of other problems, you should remember this. So you need to remember 2 square. You need to remember 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square, 11 square, 12 square, 13 square, 14 square, 15 square, 16 square, 17 square, 18 square, 19 square, 20 square. 2 square is 4, 9, 16, 25, 36, 49, 64, 81, 100. Yes, 121, 144, 169. 14 square is 4 4 is 16, 196, 225, 16 16 is 256, 17 17, so 17 17 7 7 is 49, 4 7 plus 4 11, 17, 289. So 289, 18, 18, 8 it's a 64, 6, 324, 19 times 19, 9 is 81, 8, 9 is 8 plus 17, 19, 1, 16, 361 and 400. Okay, you need to memorize this. You shouldn't spend time on calculating these things when you're solving some problems. Immediately it should be available to you. Okay, similarly 2 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube, 8 cube, 9 cube and 10 cube. At least up to 10 you should remember. 8, 3 3s are 9 3s are 27, 4 4s are 16, 4s are 64, 5 5s are 25, 5s are 125. Okay, 7 7s are 49, 49 into 7, so that is 343. 8 8s are 64, 8s are I think 512, 64 into 8, 4 8s are 32, 512 I think, 32, 3 6 is a 48 plus 3, 51. So 512, 9 9 is a 81, the 9 9 is a 72, 729 and 1000. 10 square, 10 cube, this you don't even have to memorize, it's quite simple. I'm just writing it for you. So 10 to the power of 7. Remember, whatever is the number of exponents, that means number of zeros. 2 3 4, 1 2 3 4 5, 1 2 3 4 5 6, 1 2 3 4 5 6 7. And whenever you are multiplying numbers with lots of zeros, convert it into exponents and then it becomes much more simpler. Now another kind of squares to the power of 2 powers that you should remember, it directly has nothing to do with roots, but it's nice to know, is 2 square, 2 cube, 2 4, to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. This is 4, this is 8, this is 16, 16 2s are 32, 32 2s are 64, this is 128, 256, 512 and 2 to the power of 10 is 1024. Right? Okay, so that is as far as square roots and cube roots are concerned. Now, of course, you might have realized that conveniently I have looked at only those numbers which are perfect, right? So I've looked at 2 into 2 into 2, so 2 cube, 3 cube. But what about if I want to find the cube root of 5? Right, cube root of 5, it's not going to be simple. Square root of 2, yes. So such examples we'll take up in the next session. Bye for now.